Hello, everybody, and welcome to the June PHMass, Massachusetts Open Meeting happening here live at the BSA and live streaming online. This is our first live, in-person session in over 2 years, since March of 2020. So it's exciting to see so many folks here in person and see your faces, and to have folks watching online as well. Part of the reason that we did return to in-person meetings for this month is because of this week's Passive House Network conference, Passive House for All, happening here in Boston. We're really thrilled to have the Passive House Network choose Boston for the location of their annual conference. They held it in all kinds of different places, from New York out to the West Coast, all over the place before, and now they are here in Boston. Part of the reason is because of all the great work that the folks in this room have been doing on new affordable housing projects, on new passive house projects, on incentives and policy changes, and they're recognizing that work and showcasing our city in many ways here with this conference. So the Passive House Network is the North American affiliate to the Passive House Institute, which is one of the two certification bodies for Passive House, along with PHIAS. The Passive House Institute started in Germany back in the 90s and certifies projects all over the world, and serves not only as a hub for certification and metrics, but also for research and advocacy of Passive House. So please welcome Jessica Grove-Smith, Senior Scientist and Joint Managing Director of the Passive House Institute in Germany. For those watching this recording, we did have some audio issues at the very beginning of Jessica's presentation, so I'm going to turn things over to her in progress, but you missed very, very little. She just gave an introduction on what she was going to talk about today, which is updates on what the Passive House Institute is doing around the world, and showcasing some of the great things that they have been up to. So here is Jessica.
It's a fairly random selection to just give you an overview or some insight of the types of projects, the scale of Passive House that is being implemented in different countries. So I'm not going to go into detail on the projects, but I wanted to just share some pictures of some views. So this is a project from Spain, in Pamplona. Spain is one of the front runners in terms of the Passive House scene at the moment. They're really picking up on Passive House, and specifically in the area of multifamily building. So there's some developers that are really picking up and saying, it makes sense for us, it's logical, we're going to build to the Passive House standard in multifamily buildings. But not only multifamily, they're also, if I can go to the next slide. They're also doing some office building. So it's generally a very positive vibe and uptake of Passive space. As I go through the slides and show you the pictures, I've always added the link down here. There's an international database where we show Passive House projects, passivehousedatabase.org. That's kind of the representative ID number. So if you want to just browse projects worldwide, I suggest you go to that website and just click your way through for inspiration. As I said, I've just picked out a few that stood out and that were from the fairly recent projects. So these are all from 2021 or 2022. This is a quick overview or an insight of, or an impression of what is happening across on the other side of the world in China. Passive House in China picked up a few years ago, and as it is in China, things are very big. The Passive House projects being built in China are often inside districts, which are then a mix of single family, multifamily, and high rises. So this is some pictures from a district that is being built to the Passive House standard in China. China is interesting also because it has a lot of different climate zones. So we're talking about hot and humid conditions, but also very cold conditions depending on where you are within the country. This is a project in Sweden, so cold country. And what's interesting here is that this is an unusual typology. It's a mixed-use building, multifunctional, so there's larger events, but also small sports activities. And this one is not actually a certified passive house, it's a certified low energy building. So it has slightly higher energy performance values, but has gone through the same quality assurance process as passive house. Now coming to this side of the world, this is a project in Canada, a retrofit actually, Humber College. It's a retrofit that achieves the standard kind of passive house classic criteria. Another retrofit project from Canada is this Ken Sobel Tower in Hamilton, Canada, which is going through the news quite a bit recently, which is great to see that retrofit is being picked up and implemented. Retrofit is something that we're really trying to focus on and push to address really the emissions of the existing building stock. Another retrofit project, this one is in Spain, in Barcelona, from Michel Vatouf, who's a very active and long-term passive house designer in Spain. The one that's special about this is that it's a phased retrofit. So it wasn't all done in one go, but it was done over the course of many years. So they're taking it phase by phase, and we have a pre-certification retrofit plan. So you have to plan ahead, and you can kind of pre-certify for the retrofit standard. Okay, and then of course there's Germany, where Passive House originally started in Darmstadt. This is one of the recent projects, and what's happening in Germany is that there's a lot of kind of schools being built, but a lot of offices. We're seeing quite a lot of kind of just admin buildings being built for Passive House. That's a fairly standard and common approach. One really exciting event that happened last week in Frankfurt, in Germany, is that we handed over the Passive House certificate to the very first certified hospital. That's first, it's new, it's very, very exciting, especially because it highlights the synergies between Passive House and health. So Passive House is not only about energy efficiency, there's so many other benefits, and one really apparent one is health. So it's great to see that we have this certified hospital in Frankfurt, and we've already seen quite a bit of interest from other people picking up on the same ideas. So we'll see, it's opening later this year to the public. Another very special typology is Passive House swimming pools. We started off with research on what does that mean? Obviously for a pool, you don't use the usual metrics, it's kind of the whole house approach. How do I apply energy efficiency for such complex projects? We started off the research in 2009, 2010. There were 2 pilot projects in Germany. And then the latest project, which is now open and about to complete certification, is St. Tidwell's Point. That's a leisure centre in Exeter in UK. And it's a great way of seeing how Passive House can be applied as a concept and as a standard for different typologies and complex typologies. So it goes through this research phase. We then have bespoke criteria for these projects. And Exeter is a great example of seeing the ripple effect. So Exeter was really ambitious and said, no, we want this. We commit to these climate targets. We want to do something differently. They built this. And ever since St. Tidwell's was kind of on the radar and they started talking about it as Exeter City Council, we've been approached by municipalities saying, we've heard something, we've heard really good things, we also want to do this. I could probably fill my job or another job just consulting on leisure centres. So that's also very exciting. And obviously in terms of absolute terms, a lot of energy savings, optimized pool projects. Okay, so that was just a few pictures and typologies to give you an insight of what's happening around the world. This is just similar statistics to what I showed you earlier in terms of where we are in the world. On the right-hand side, you can kind of see the growth of the very early passive house, very first passive house, to where we were at the end of 2021, divided by the different regions. And obviously, passive house, international passive house standard is still largest in terms of the square footage in Europe. The next is then Asia, with China being extremely dominant, and then there's North America. Looking at these numbers in North America in comparison, they look quite small. But what's really fascinating here is if you keep a little bit an eye out on what's happening right now here in North America, that's about to explode pretty drastically. So again, just a few pictures, see where we're heading, but it's certainly growing. And a lot of the projects here in North America are large. They are quite big in terms of the square footage that they're actually covering. So University of Toronto, for example, has a student residence, University of Victoria, student housing with commercial or with kitchens, which is also very, very interesting passive house approach. There's a fire hall in the city of Vancouver that is undergoing certification. Tower project, this is the Nelson Tower, also being planned and aiming for certification in Vancouver. And then obviously here in the US as well, there's quite a lot happening in New York. This is the Sendero Verde project. This small part is about to be certified. And then these other sections are also aiming for certification, still under construction. So very exciting to see all of these projects finally actually coming online and showing up in the statistics, being complete and being there as kind of pioneering pilot projects. And I really hope for that same ripple effect that we have seen in Exeter and so many other pioneering projects. Another really important one or interesting one is the Torello building. That's a retrofit, a large-scale retrofit project, also on the radar here in the US, in New Haven, which is being reused, turned into a hotel. And then, of course, we have here in Boston, the largest project that is happening right here, right now, is the Winthrop Center, which is also aiming for passive house. It's very special. It's a pilot project, and it's unique, A, because of just its dimension and its size, and B, because also only part of it, so the office part of it, is being certified. So we're very excited about this coming online as well. Okay, so much for kind of an insight into projects. Now speaking a little bit about PHI and the Passive House Institute and what we do, what our areas of work are. So yes, I've come from Germany. We are based in Germany. We have 2 offices, one in Germany and one in Austria. And we were founded originally in 1996, really as a research institute to bridge the gap between the research, the technical knowledge, but the practitioners. So to kind of see where are we trying to get, what is possible from a research perspective, and how do we give that knowledge to practitioners so it gets implemented and actually impacts and makes a difference in the way that buildings are being built. So we're all about quality assurance. We're all about kind of safeguarding the standard, defining the standard, and then providing quality measures and support for uptake. That's basically what we do. We're based in Darmstadt in Germany, and then we work with partners internationally who then help to advocate and to spread the passive house knowledge in their specific regions. I'll come to that a little bit later. So reflecting briefly on the different programs that we have, obviously the passive house standard as it is defined is kind of our guardrail. That's what we're aiming for. This is by now the different programs that we have. So it's not just passive house, passive house. We now have these different levels of certification. In the top row, you see the passive house for the new builds, where we have passive house classic, passive house plus, and passive house premium, so 2 different tiers. Similarly, for the retrofit, so we have a separate retrofit standard. Again, I'll explain it in my next slides. And here, again, we have the different tiers. So we have EnerPHit Classic, we have EnerPHit Plus, and EnerPHit Premium. Now, the difference between these different tiers, from Classic to Premium, is that the Classic has remained kind of with the passive house baseline, which is focused. Which is focused on energy efficiency. So it's really looking at the fabric performance, it's looking at achieving your heating and cooling energy targets, but not looking at any kind of energy supply, renewable energy supply. Whereas the Plus and then the Premium, you get awarded if you have renewable energy production. Whether it's on-site or off-site, as long as it's new renewable energy production, you get Plus, or if you have even more, then it's the Premium standard. The Plus and the Premium also have a slightly more stringent overall, so your primary energy target is a little bit stricter. So it's more ambitious, basically, going to Plus and Premium, and we're trying to encourage and move people to go the extra mile and not only focus on energy efficiency, but also include renewable energy generation. And then we have this standard, which is a lot less known, which is the PHI Low Energy Building Standard. And it's basically, it's focused on new builds. It's slightly less efficient than the passive house. So the target is a little bit higher in terms of the heating demand, and it's a little bit less stringent in terms of the comfort requirements and the air tightness requirements. The reason why we introduced this is because, I mean, what's at the heart of the passive house is really the quality assurance process. Working with the PHPP, having the people on board to make sure that the design process is good, that you have the quality assurance. And it seems kind of harsh to say it's a complete hit or miss when you're on that 4.75 for your heating. But we wanted to award projects, especially in new places, in challenging climates, with a challenging setting, to still get some kind of award and recognition of having gone through that quality assurance process. So that's why we introduced this PHI Low Energy Building Standard. Okay. So these are the numbers for the different classes, Classic, Plus, and Premium, in the context of new builds. And I apologize, this is SI unit. Always, yeah. And I don't know how fit you are to translate that into IT on the spot, but Yeah, so basically what you see on the right-hand side is your total primary energy, renewable primary energy demand. So the higher the tier, the more efficient your project has to be overall. On the left-hand side, you see the requirements for the renewable energy production. So Passive House Classic doesn't require production, whereas Passive House Plus and Premium do. And Premium is double of Plus in terms of the production. Now, if you look at this in some detail, you'll notice in the fine print that the actual square meter for the reference is different. Whereas energy efficiency, as has always been with passive houses with respect to treated floor area, the energy production is with respect to the projected footprint. So that's basically just looking down at how much space is my building covering. We did that deliberately in terms of, it is an alternative, it's a different approach to the net zero, which is commonly referred to or kind of often used by, yeah. And the reason for this, to have the independent rating of energy efficiency and renewable energy supply, is basically that we don't want to penalize any kind of commercial, tall, shaded or urban infill projects. So this kind of project in a net zero scenario doesn't stand a chance, just because the space at the top for your PV is so small in comparison to your treated floor area. And that doesn't seem fair. And it guides people to build kind of single-family houses spread out, and that doesn't seem a very sensible design incentive. So instead of pushing people for net zero, which can be very, very misleading, we have this independent rating of energy supply and energy demand. So we just say, okay, your building occupies a certain amount of space, and it makes sense to use that space as efficiently as possible for renewable energy production. And that's how we rate renewable energy supply. That's why it's per projected footprint. Okay. Now, in my previous slides, I used the term renewable primary energy, or PER, quite a lot without actually explaining it. This is also something that is very specific to the International Passive House Standard. We introduced it in 2015 for the first time, when we introduced the different passive house classes. And we introduced it as a different metric and alternative to the standard source energy approach. Just because we are in the position worldwide, the energy supply is transitioning towards renewable energy infrastructure, towards electrification. And what we need to be addressing as a building industry is to make sure that buildings are designed in a way that they will work and they support that renewable energy infrastructure. Now, the difference with renewable energies is that they're not available at all times, right? It's only when the sun shines, or when we have wind, or when we have hydropower. So it's really important to look at those aspects of load matching. So what we did basically for the PER concept, it considers your building in the context of a scenario of 100% renewable energy supply. And then we have conversion factors to see, okay, how much renewable energy do I have to feed into the grid in order to be able to cover my site energy, the actual building energy demand. And that loss factor, that conversion factor, takes into account the load mismatch. So it takes into account how much losses do I have along the way because of storage, because of seasonal storage. And that can be quite significant, overall. It's a big topic, PER, which I can't dive into detail right now. I'm happy to talk about it later on, or point you in the direction of resources to read more about it. It's very important to me because it's one of my research topics, but we've also seen a really interesting kind of feedback from the passive house community and also from policy who are looking for these kind of design incentives. What does it mean to have buildings in the context of renewables? Basically what it does, it's a climate-specific decarbonization metric. So it's based on really efficient, or it's addressed towards efficient use of regional renewable energy resources. And what it does, basically, if you apply it to your design, is it really strongly incentivizes electrification instead of using fossil fuels. So with passive house planning, you'll get a better PER factor with a heat pump electrical solution than with a gas boiler, which is the direction we're all trying to push towards. It also means that it aligns kind of energy demand and renewable energy supply. So the fact that the difference for heating and for cooling, it's much more important that we reduce the energy demand for heating than for cooling, and that's what the PER concept also picks up on. And last but not least is we have a budgeted approach to biomass. It's not so relevant here in North America, I think, but it's a topic in many parts of Europe that projects are being just rated as very green and clean and sustainable if you have an inefficient building with a wood burner, and that's also not a long-term sustainable solution. So we have a budgeted approach. Some biomass is fine, but not to heat an inefficient building. Yeah, so that was a quick run-through for PER. I do want to speak a little bit more about our retrofit standards, our EnerPHit, because that's just starting to pick up here in North America, but I don't think there's many activities yet here in Massachusetts. Yeah, so it's the EnerPHit standard, we call it. It's a retrofit standard where basically the idea is you apply the same concept, the same idea, you implement passive house components to an existing building. And there are two approaches or two pathways to achieving EnerPHit certification. One is actually a component pathway, so you have to meet specific minimum requirements for your components, for your insulation, for your window, for your airtightness, and so on. Or pathway two is there are specific energy demand limits. And those limits are higher than for a passive house, in order to recognize that for an existing building, it can be a little bit more difficult. You have some thermal bridges, especially in the ground area, that you can't kind of build to the same standard as a new build. You have to deal with the orientation and so on and so forth. So the threshold is slightly higher. And both of those pathways are differentiated depending on where you are in the world. So they're climate specific. The targets, the numbers are slightly different for the different climate regions around the world. And again, a slide in SI units, just to give you an idea of what it's about, and the actual numbers can be looked up on our website. Basically, we define the U values or R values for the windows, for the walls, and the efficiency of the heat recovery requirements for the different climate zones. That's if you go down the component pathway, or if you go on the energy demand pathway, there's the different targets. So cool temperate is what we typically have in Germany. For passive house, it's 15 kilowatt hours, so that's 4.75. Yeah. And for EnerPHit, it's 24 kilowatt hours per square meter in the year, 129p. So not quite double, not quite double, but it is a bit higher. Yeah. Yeah, so retrofit is something that we're really trying to promote more and push more for, as I was saying, because it's really important. Now we have one additional scheme, I mentioned it earlier on, and that's kind of to address all those projects that aren't able to, or where it doesn't make sense to do retrofit all in one go, but you have a phased approach. So you only replace the windows because they need replacing, but you don't have the financial means, or it doesn't make sense to look at the insulation at the same time, or the other way around. Maybe your windows are still in a good condition, so you do the insulation first, but you leave the windows. So that phased approach. Now the difficulty with those phased approaches, and what often happens, is that we create a so-called lock-in effect, because people will look at the wall insulation without thinking ahead in terms of, okay, what does that mean if I replace my windows later on, without looking at the details beforehand. So what we offer is the so-called EnerPHit retrofit plan, which basically is an extra tool, and it aids you in documenting what is my timeline for my different components, and what do I have to keep in mind. If I do my walls first, what does that mean in terms of what do I have to think about in terms of connection details, or the other way around. So we offer this retrofit plan, and you can get pre-certification. So if you've set out this entire plan, and you've implemented the first step, you can submit that to PHI or to an accredited certifier, and you can get pre-certification to basically acknowledge that you're on the right track towards achieving EnerPHit certification in the end. And I'm personally really excited that this is starting to pick up. It was really difficult to get this rolled out, but it is starting to pick up, especially in Austria. So this is really, really exciting. It's worth looking this up again. We had a webinar on it in November from our colleague in Austria, Laszlo Leff, and he presented some of the projects where this phased approach has been implemented in Innsbruck on multifamily buildings. So you see some of the projects in the background. And this is basically the EnerPHit retrofit plan and the pre-certifications that they had set up. And you can see these are kind of the different steps. So this is the passive house, or the project, sorry, before it was renovated. Then they have step one, where they only did part of the windows and part of the ventilation. So only some of the units were retrofitted. And then they have a second step where they completed the windows, but didn't touch the ventilation. And then in the final step, they did everything. They completed it to kind of the EnerPHit standard. What you see here is how step by step the heating demand decreases. Just some pictures to show that this is reality and not just on paper. This is what the project looked like beforehand, what it looks like afterwards. They have some really interesting details here in terms of how they dealt with the balconies. On the other side of the building is full of balconies, so it's really interesting to look at that thermal bridge details. Here are some details of how they dealt with the ventilation. Most of these projects also retrofitted while the people were still living in them, so they had to find a way to do this with as little kind of disruption as possible. Again, here, this is the ventilation within the apartment themselves, so installing the ventilation system in the hall, and they did it pretty quickly. So it was important to the developer, in this case, to have smooth implementation. So just a brief insight into this. If you'd like to learn more about it, I'm happy to point you in the direction of the resources. The webinar should be going online also, at least for members. These kind of webinars are available to access and to rewatch. On another topic of retrofit, this is something that is ongoing at PHI. So this is some of our current research work. It's called the EnerPHit project. So a lot of our research work happens or is enabled through funding from the European Union. This is one of those project EnerPHit where we as Passive House Institute in this case have the lead, and we work with partners in different countries of the EU to further the research and to implement this in pilot projects. And the goal of this EnerPHit is really exciting. It's really up to date and really important. It's about lowering the barriers of uptake of really high energy efficiency solutions for retrofit. So essentially one-stop shop solutions, prefabrication, and being able to distribute that on a larger scale. And that with the aim of being able to implement the EnerPHit standard on a large scale. That's the goal of EnerPHit. We're still in the middle of the project. Some case studies were presented in the virtual part of the conference last Friday. So some of you might have seen it. So work in progress and something to certainly watch. This is an overview of the pilot schemes that are taking part in different countries across the EU. So again, there's a variety. There's single-family houses, but mainly multi-family buildings where this is being implemented and studied. As part of this project, we're also looking at different kind of detailed topics. One of them was summer comfort, and one really important one is embodied energy evaluation. So what we've done is we've set up a new tool. The initial phase has been released, so we're going to be refining it throughout EnerPHit. And the idea here is really to be able to make an assessment or to give the user feedback in terms of how does the additional embodied energy for additional materials for the refurbishment compare to your actual operational energy savings. So work in progress, but also very exciting to see that. It's quite interesting to go into the results of this because it shows clearly, well, not clearly, but it does show that it's worth investing in extra insulation compared to the operational energy savings that you have over the lifetime of the building, especially for retrofit. That it does really make sense. And it's quite interesting to see the comparison of different materials. Not always intuitive, so very, very interesting. Okay, so for the last section of my presentation, if I still have a moment, Aaron, it's okay, yeah? I wanted to touch a little bit on those three focus areas. It's basically the design tools that we need, it's the people and the expertise, and then it's the components and their quality. Those are really the three main ingredients that we as a Passive House community need to be working on, need to be pushing, need to be distributing and make them available in order to make sure that passive houses that are being built reliably achieve a high performance. So I just briefly want to speak about these three different categories. Passive House components, we from the Passive House Institute run a certification scheme. So we work with manufacturers, help them to optimize products, or if they have good products, then we offer certification. And here you see kind of the growth of Passive House component certification over the years. There's different categories for building service, for transparent building envelope, or for opaque envelope, so building systems basically with the details already involved included. Sorry. Yeah, so we're seeing growth here. Once a product is certified, it goes online into the Passive House Components database, which you can access anytime. Here you also get an overview of kind of the different categories we have. And we have added a few new features for this component database to make it a bit more accessible and a bit more attractive, a bit more user-friendly and useful for everybody, really. So there's a search function, which makes it easier if you're looking for a specific product, for example. You can sort by country and availability. So you can say, is this product available in the US or not? And new, what we started implementing is export to the PHPP. So if you click on a window, you can click by button and get those specifications integrated into your current PHPP energy model. At the moment, for transparent building envelopes, but we will implement that for other components step by step. What I don't have a slide for, but what is important to note is that we're trying to push more for certification of heat pump systems. So we have a certification scheme for split units for heat pump systems. So we're trying to support that market uptake. It's a really difficult one to assess the efficiency of such systems, but we're happy to work with manufacturers and really want to move that forward. Then the people, all of you and beyond, Passive House training is super, super, super important for spreading the knowledge, for really driving change. We need to make sure that people know what it's all about and how it works in order to be able to implement it. We're celebrating an anniversary this year. It's 15 years of the Passive House Designer certification. It's 10 years of the Certified Passive House Tradesperson certification. So those are the two main tiers that we have, for designers, consultants, and for tradespeople. I'll say a bit more about those programs in a little bit. There's another level of expertise, which is really important, and that's the Passive House certifier. So people who are really, really experienced can go through the certification training with us at Passive House Institute, at PHI. They can become accredited certifiers and then certify passive houses to the Passive House standard in their region. And that really helps us to grow Passive House internationally. So projects don't have to come all the way back to us to Germany for that quality check, but can go through those accredited individuals in the different countries. So that's really helping us to grow the movement. And here in North America, there are around 13 certified individuals, active people.
13 organizations. There are over, I think, 25 individuals.
And they kind of come together as a group as the North American Certifiers Circle. And Passive House Network is also doing some really good work to inform the Passive House community here in North America in terms of what certification is all about and why it's important and how you can approach a certifier. So that's worthwhile looking out for and tuning into if you have questions about PHI certification protocols. This one is not really about training, but it is about expertise and knowledge transfer. I wanted to make sure to mention it without going into too much detail. Passipedia, I don't know how many of you are familiar with it, but Passipedia is kind of our online wiki for Passive House knowledge. Growing all the time, we're tidying it up a bit at the moment. There are two new sections which are certainly interesting and relevant. Three actually. One is on guides. So where we published the guide for pools, the guide for commercial kitchens, for kitchen extract hoods, and the guide for hospitals. And then there's another section which is new, which we've tidied up a bit, which is specifically on tools. So any kind of supplementary tools for the PHPP, which you can download on Passipedia. And then in terms of knowledge transfer, we have the International Passive House Association, which is really, really important in terms of interconnecting the international community. So PHI focused on research and quality assurance, as I was saying earlier. But part of our office, part of PHI, is also the International Passive House Association, and that's a member-based international organization. And then we have affiliates in different parts of the world. Here in North America, it's the Passive House Network, it's New York Passive House California, and Passive House Canada. They're directly affiliated, so they're direct affiliates of the International Passive House Association, and thereby by Passive House Institute. So all members of these organizations automatically become members of the international community and get access to all that international expertise and knowledge transfer. So speaking a bit more about training, that has also evolved quite a bit in the recent years. So it's not only Passive House Designer and Passive House Trades, and that's it. What was important to us to say, it's important to keep learning. There are so many different levels you can go into. There's so many different specialities. So we've kind of added, or we are bit by bit adding specialities to these different sections. So for example, looking at a construction verifier or a site supervisor, or we have a special training for component assessors, somebody who can kind of work with the manufacturers and look at efficiency of components. Something that we're hoping to roll out this year is a focus on retrofit. So kind of an add-on exam that you can do on the focus of retrofit, and then you basically be a passive house designer with retrofit special expertise. So that's something where we're kind of diversifying and increasing the training capacity. Now the tools, a really, really, really important part of Passive House. We wouldn't be able to achieve Passive House without these verification methods. PHPP has been part of Passive House from the very, very beginning. It's our energy balance model. That's what we use to optimize the design, and it's the core of Passive House certification, really verifying where is my energy performance at. We have just released Passive House PHPP version 10 in English last month. We're setting up contracts with resellers so that you can also access it here in North America. Not quite ready yet, but soon, just a little bit more patience. It is available in English, so you'll be able to access it soon. And I'll give you an overview of updates in a second. Next step is to translate it into IP version, and that'll be within this year. So I don't know how many of you work with SI. If you do, you'll be accessing it sooner. If you want to wait for the IP version, that's a few more months to wait. But we're on it. So what's new in PHPP 10? And I'm only going to briefly run through this, and then I have a workshop on Thursday, where we're running into a bit more details on these different features and what is new within PHPP 10. There's a few new features, worksheets, and tools. The core of the PHPP in terms of how we calculate the heating and cooling hasn't changed. That's the same, that's worked, that didn't need an update. So it's really about adding new features to the tool. One of them is an integrated risk assessment for summer comfort resilience. So that's especially important for projects without active cooling, because we've had feedback, climate is warming, there's a risk, really high risk of project overheating. It's very dependent on user interaction. Do they use the window ventilation? Do they use the shading? So far, PHPP had just one number for the frequency of overheating, without any feedback to the designer in terms of how robust is that number. So PHPP now includes an integrated risk assessment to give you feedback on how robust your design is in terms of summer comfort, or whether you might want to reduce the glazing size, for example. Number two is a template for easy comparison with monitoring data. So basically, if you want to check your performance of your building compared to the PHPP, you can input your actual monitoring data from the temperatures or from the actual weather data, and then the PHPP will automatically kind of make a comparison between that performance and your PHPP modeling. In terms of electrification and heat pumps, again, a topic that is important to all of us, we have added kind of new component categories and a slightly different way of how we model heat pumps, combined ventilation heat pump systems, and split units in the PHPP. We've also adjusted the data entry for windows and curtain walls, which makes it a lot easier, especially to deal with large window and curtain wall systems. We've added a project overview worksheet, which quickly and easily gives you kind of an overview of where your project stands. The idea is there also to be able to link it with the online database so that we easily kind of get that information online. And then there's some supplementary tools like a room-by-room schedule where you can easily keep track of the different rooms and different room ventilation rates. Yeah, so those are kind of the main new features, and then there are a lot of kind of small changes and additions within the different PHPP worksheets. For you guys, it's not such a big deal. For people in Australia and New Zealand, this is huge. PHPP 10 is going to make a huge difference because it now also works fluently on the Southern Hemisphere. Beforehand, you had to kind of switch the climate data and pretend it was on the Northern Hemisphere. So that's a big change for many people down under. Yeah. I don't know how many of you are familiar with the variant calculation. So there's a variant worksheet in PHPP which lets you look at different variants of the same building at the same time. We've extended that to include PV and solar thermal. In terms of hot water systems, we've added some new features for heat interface units. So it's a different way of, I never know whether heat interface unit is the right terminology in English. It's basically you have the same heat distribution as the heating system, and then you have the heat exchanger in the flat for your hot water system. So it's a different way of modeling your distribution losses, basically. Yeah, and then another change, which doesn't affect the PHPP itself, but does affect user-friendliness. So instead of having a printed manual, you can access it online as a flip book, which makes it searchable, digital, which is a lot easier in terms of using. DesignPH has been updated. If you're already working with version 2, you've got access to the updated version 2.1.10, which is compatible with PHPP 10, basically. That was the main update here. For those of you who don't know DesignPH yet, DesignPH is basically, it's a plugin for SketchUp, which allows you to do a quick and easy energy balance within your 3D model to get an idea of where your design stands, and then you can export all the information into PHPP for then further refining the model. With new PHPP also comes the update of the Passive House criteria document, which has also just been released in May 2022. Again, the criteria as such, the Passive House standard hasn't changed, but it has been quite a while since we issued the last release of the criteria, and a lot has happened in the meanwhile in terms of Passive House growing. There's been different typologies. So a lot has kind of become standard practice, but hadn't yet been actually formally written into the criteria yet. So all of that, or a lot of that, has been integrated into the criteria. Just a brief overview again over the changes. There's some changes to the energy demand and load criteria in terms of simplification. So we've taken out the criteria for cooling load because it wasn't really helpful in terms of the design choices. What's really interesting and important is the project-specific primary energy demand for densely occupied buildings. So this is specifically or especially relevant for densely occupied multifamily buildings where you have a lot of people, a lot of electric equipment in small space, where the standard primary energy criteria from Passive House is really difficult to reach. So we've developed a tool, and that's now integrated into the PHPP and integrated into the criteria that you automatically get an allowance or bespoke criteria for that specific project. Yeah. There are some details that have changed in the criteria with respect to the comfort and hygiene requirements, which are now specific for the project and specific for the climate. And we've relaxed requirements for the door thresholds just to make it easier and remove one of those barriers that has often been a problem on implementing. And then just some clarifications on the boundary conditions and the documentation required. So really, we've restructured it a little bit. We hope we've made it a bit easier in terms of accessing the information and flicking through that catalog of requirements for Passive House.
Is it available now?
Yes.
Online?
So the criteria is available online on the PHI website.
Is this summary available there as well?
No. The criteria does include, actually, yes, it's not the exact same wording, but it does have in the front section a summary of changes. And the rule, as always with Passive House, really is once you can finish a project with the and with the criteria version that you started a project with. But new projects coming online now need to work with the PHPP 10 and with the updated criteria. And as of now, as of this iteration, we will be updating the criteria on a regular basis, on an annual basis, releasing and just making sure that all the new additions, all the refinements are available to everybody and get written into the criteria. Yeah, so I'm really coming towards the end. Just the final word, final thinking. Yeah, we're based in Germany, but there's so much happening around the world. It's impossible to keep track of it. So it's really all of us, all of you guys are making this happen in your specific region. We all work on this with a global aim, with a global standard, with a global idea, but it's really important to act within your local. Yeah, so thank you for that, for your time. I'm happy to take questions. I hope I was able to give you an insight into what's happening at PHI, and I really look forward to today and also the rest of the week of Passive House here in Boston.
And we do have time for questions. What's happening?
CE requirements.
Sorry, say that again?
The CE requirements.
To remain once you have a Passive House certificate?
Yeah,
No. No, so once you have a certificate, you have the certificate unless you make substantial changes. So if you add a part of your building or if you, I don't know, make substantial construction changes, then the certificate becomes invalid. But generally, once you have the Passive House certificate, you have it.
You mean for an individual? Or you mean for a certificate?
Sorry, you meant as a trained, sorry. For continuing education, yes, the certificate is valid for 5 years. And the standard certificate is valid for 5 years, and you can, in that period, collect credit points by attending events such as this one, such as the conference. And you can collect credit points and then apply for another 5 years, basically. Or, alternatively, and that is actually the preferred route, is you can build a Passive House, and you can document that very detailed, and then you can submit that as application in order to say, okay, I know what I'm doing, I know how to build Passive Houses, we evaluate that, and that can also kind of count as your accreditation to become a designer or to extend your certification.
I'm very interested in what you said about adding the summer comfort resilience assessment. I've been kind of thinking as we look at climate change, we talk about resilience. We're here in New England, and we think of that as winter. We say, oh, we can coast through a power outage. And I think, well, how does that work in the summer? We don't have any active cooling, so something out there off the heat gain from the outside, but that's not going to be necessary. I'm curious what thoughts you have about how you're doing that assessment.
Are we talking about buildings with active cooling or without active cooling?
With active cooling, but when the power's off. So not active cooling.
Suddenly,
From a resilience standpoint.
stand that power outage and be comfortable.
Yeah, we think of power outages in the winter, we say Passive House is wonderful, you can coast for a week or whatever.
Yeah.
How long?
Same, to be honest, same for the summer case.
No.
You're still, yeah, especially, yes, because your building envelope, your airtightness, your insulation is giving you a buffer. It's protecting you from the outside.
It's giving you a buffer, but you're keeping in your internal heat.
Yes, and that is really, really important for any building, regardless of Passive House or not, is that you need to be able to ventilate, right? The better your building is insulated, the more important it becomes to be able to release heat overnight by opening windows.
Right, but this is the problem. I live in a Passive House where I never use heat in the winter. Really, I never have to use it. In the summer, I do night cooling until we get into August and doesn't work. Because it's too warm and humid overnight to cool. So if I have I'm using cooling, if I have a power outage in that period, I think resilience becomes a questionable.
Yeah, okay, I'll get back to the point of resilience in a second, but I mean, it's still equivalent to the winter case. If you have a power outage in winter, your building is going to get cooler over time. In summer as well, your building is going to get hotter over time, but your passive house is going to heat up slower than a non-passive house.
Definitely slower, and I question
Which is
the
your
concept
resilience.
of resilience.
Well, I'll throw in one concept is that I think many of the houses, buildings don't have proper solar protection. So you're not people are optimizing the insulation, but they're not optimizing the solar protection. And that's one thing we need to all take more seriously. If you've got the solar protection, it will stretch it quite a bit.
And
Yes, I would agree with that.
And that's what this is trying to help with. I mean, it's not you still have to kind of think about your building design. You still have to know what you're doing. But what this stress test really helps with is that instead of just plugging in a number on the assumption of your ventilation rate or plugging in a number on your shading, what the tool now does is it checks, okay, what happens if your shading fails or if people don't use the shading as you thought they should in your PHPP model, and it gives you feedback in terms of how far will your building, in that case, overheat. And if your overheating then overshoots, that is a clear indication that it makes sense to change your design, to have smaller windows, to have a fixed shading element. So that's what this intends to do, to reduce the risk of relying too much on unknown factors, whether it's the internal heat gains or the user interaction for ventilation and shading. That's what this is trying to address.
Does it also include in the future?
In a simplified way, yes. So, I mean, PHPP doesn't have the capacity to calculate climate projection. That's a topic in itself. But the climate stress test does check what happens if your summer temperatures are 1.5 degrees higher. What happens in that case? That's also part of the stress test.
I'm going to cut off discussion for the moment because we're at 7 o'clock, but we can continue to meet here. You can ask Jessica questions one-on-one. You can talk to Ken. We've got the others in the room. I'm sorry, Brown, I did see your hand up, so go ahead. Well, excited to talk to you in a moment anyway, but thank you guys, and Jessica, thank you so much.
Thank you.
Yeah, and feel free, have some more beverages and talk.